from my standpoint.
Alright.
I'm Josh Dermer.
I'm Carl Aquino.
This is our Bear Spots parking space arguing project for junior honors engineering. The overview, I'll be going over the project goal and the IP camera. Josh will be covering the classes and algorithms. And Carl will be going into the results and future work. We'll finish with questions. The project goal, as Dr. Craner alluded to it, and Brian corrected him, there is a housing problem if you're a residential student. Unless you're coming to the engineering lot or the baseball lot any time of the day, it can be questionable whether you'll find parking in a reasonable manner. So obviously, for project goal, wanted to allow students, or just us for now, to determine where we could find parking space in a parking lot. And so for our purposes, we decided to pick one of the small slots on campus, which is actually the Mercer Medical School lot for patients. It's very close to the engineering building, and it's just easy to get data from because it's so small. So we'll take the parking lot and the IP camera, take a photo stream of the parking lot, stream it to a computer, which will take the parking lot image, break it up into a bunch of parking space data, and then our algorithms will determine what spaces are available or not based on the color pixels in the parking lot. And eventually we'll stream that to a web server that you can pull information off of from your cell phone or just a computer. Overview. The first thing we acquired and introduced John was our IP camera. We determined a Foscam outdoor wildlife camera. It was a $99 camera. One of the major things we were looking for is it had a free server that we could connect to. We didn't want to have to spend a lot of time setting that up. Wanted to make sure it was wireless, 11 in. Had a big enough display resolution that we could actually get enough pixel data. This isn't high def, it's on the lower end, it's 40p, but anything outside of this range was outside of our budget for the project. And we wanted to make sure that it was fast enough, giving us photo stream fast enough that we can analyze. It's 30 frames per second, which is much faster than we need. We only need about anywhere from 30 to 15 frames per minute that would really analyze the parking lot and tell you what spaces are open, because cars don't move 30 frames per second, really, in a parking lot. And additionally, the camera had infrared capabilities, which we don't know if we use right now, but for future work, we could take infrared photos.
Thank you, Kyle. The next section we'll be going over is the classes and algorithms used. This project was very heavily programming oriented. Other than the IP camera, almost everything we did, we had to do on the computer. So we ended up doing a lot of programming. We wrote our programming in C++, and we created these classes to use as objects in our programming and our code to just help us organize our code a lot better and make it easier. So the first class we created was a parking lot class, which in essence just contains an array of parking spaces as well as the coordinates of those parking spaces. Then the parking space class contained an array of pixels, which we also created a pixel class which contains the actual individual RGB values of each pixel in the image for the parking space location, and it contained the XY coordinates of the location of the pixel in the parking space. The algorithms, we ended up having two separate algorithms. The first one was just a general algorithm for the entire cycle of checking a parking space, determining if it was empty, and then going back through the entire lot, taking the image in again, checking the place. And the second one was comparing the empty lot image that we use to the current lot. So the first algorithm, essentially at the very beginning of our code, we read in an empty parking lot image. We take from the image which spaces, what the location of all of the spaces in the parking lot by determining white lines and empty spaces. Then we take in the video camera feed from the IP camera, and we convert the video feed to an image that we can process. From the image, we take in the parking spots, and we compare the parking spots in the image to the parking spots in the empty lot image that we created earlier. And we compare the parking spots pixel by pixel, and we output which spots we determine to be empty parking spaces. And then we repeat that process by taking in more feed from the camera. The next algorithm essentially just details the comparison process between empty lots and the images we keep taking in. So we start by loading the empty lot image. Then we compare the spaces pixel by pixel by their RGB values. The way we did this was for each RGB value that's on a scale of 0 to 255, and as long as the red value was within 25 points of the empty lot image's red value, the green value was within 25 points, and the blue value was within 25 points, we considered that pixel to be the same as the empty lot image pixel. And so we stored that pixel into an array of booleans that we created. And we did this for each pixel in the parking space until we had compared all of the pixels. Then we looked at the array of booleans of true-false values as to whether the pixel was the same, and if 80% of the pixels that we tested were the same as the ones from the empty lot image, then we determined that that parking space was empty. And we outputted the value for that parking space to be empty, and we repeated this process for each parking space in the parking lot. And Carl's going to discuss the results and future work.
Thanks, Joe. Alright, so our results, what we have working in progress right now is that the IP camera transmitting the video, just basically getting a feed from the camera, the program reading in video and converting to image, comparing the parking lot to an empty parking lot, which basically, once we have like a picture of an empty parking lot, that's what we're going to be comparing it to, and then outputting the empty spaces, like having a display of what we get after we run the algorithm. So what the empty lots are, we're going to have a graphical display of where the empty lots or empty spaces are. What we're trying to do right now is convert the image to object type parking lot, and then because right now we're working through some Mercer's firewalls. We're using a private network through Dr. Choi, and so like we're trying to fix that so we can run it through Mercer's internet and just testing our algorithm out. And for future work, going further into this project, we're trying to develop a better algorithm, since right now we only have a basic one that we're running through let me rephrase that. Our algorithms right now are strictly based on the parking lot that we have, since we're viewing it from an awkward angle, and so like our algorithm would be like is strictly suited for that. But as we go on to further on our project, then we can enhance our algorithm so that we can have just one algorithm per like sections of parking lot. And like I said, we're trying to just develop a graphical image so that we can use our phones to just check where the empty parking spaces are. Any questions?
Questions?
I have a question. Did you do anything about a day-night cycle? parking during the day, parking at night?
No, that was part of the capabilities we were hoping with the camera we would be able to do, but day-night cycle.
Oh,
is
yeah,
first.
we had a couple of ideas on it. One of the things is we're going to take a blank photo from every hour, every day, and that would be our new comparison. We're aware that the pixels will change based on just shadows on the parking lot as well as the amount of lighting. Obviously, you can't really compare a photo at night to a photo at day because the amount of pixels are just going to be completely different. Everything's just going to be darker, and it's going to be off by more than just 25 pixels.
So your image, are you just sending that to a PC to be processed?
Yeah, the DDNS server, you can just log in and it streams motion JPEG images, and you can pull a JPEG out of there at a controlled rate, and then your computer will just analyze the.
Okay.
Yeah.
So I mean, eventually when you interface it to like a smartphone, purpose, would it tell you like the number of spots that are empty, or would it show you like a picture?
Our goal was to be a picture with the spots that were empty being highlighted.
Okay. What exactly is a Boolean?
It is a programming, a way of storing programming values. It's basically just either a true or a false. It's a variable that's always true or always false.
And then my other question, you said it was an awkward angle. Did you do anything about maybe a bigger car blocking 2 spots because of the angle, or?
We'd address that. We have 2 algorithms that we're using for the comparison. One is just to look at the flat color in the parking lot space and determine what pixels are different. The other one is to look for the white lines, because we also recognize that our algorithms, when we just look at pixels, would have a harder time determining if a black car was in the space or not. And so this also addresses if a black car is in the space versus a white car is in the space.
How many spots are you actually monitoring at this point?
The parking lot out there is just, I think, about 15.
From the camera angle we have about 5 spots.
Okay. I was just curious. It's fine. I mean, you don't want to try and monitor 500 right out of the gate. You
Mhm.
monitor a few and make sure that.
That also brings up a question for the actual definition of the camera, because our pictures is a little bit more, like I said, it's 15 spots, but only the first 5 give you a variety of pixel information to actually perform the algorithms.
And then you said the camera was infrared. Does that mean it has night vision, or it can monitor heat signatures?
Heat signatures.
It can monitor heat signatures.
That's what infrared is.
Okay. 'Cause that could be an interesting, not for you guys, but for future work, for someone to figure out the parking habits over at the dorms, and possibly, as you can see, do cars sit there for long periods of time? They show up hot with hot engine and then cool down, or people in and out of the spots a lot. 'Cause it sounds like you're telling me that when they planned these apartments, they didn't accurately account for parking requirements.
Which apartments?
The campus apartments, is that?
Oh, the lofts?
Yeah. Or is
It's
it just
just
all campus
all
housing?
campus residents.
It's
All of on-campus housing.
it's basically just all on that side of campus.
The
It's
sum of
difficult to find.
occupants and the sum of parking spots are not equal?
Not entirely at all.
Thank you.